find projects that have successes and then identify ways that they were successful. So call people, try to find resources on the internet, and not necessarily what the end solution is, but more the process or the path that that design team went through to come up with that that final solution. And this was one that I think is really challenging within branch pattern, but also I think challenging within our industry is we have municipalities that are pushing us, which is fantastic, pushing us to energy efficiency design solutions. Our codes are catching up to that, but from a design standpoint and a construction standpoint, I believe it's going to be really difficult if we don't have a really good plan in place to hit those goals that we have to get to net zero carbon or net zero energy. So next poll question here is, if you can pull that up, Danny, how many projects do you set goals for occupant comfort, health and wellness, energy, and long-term costs? I see that I have skipped over a poll question. Sorry, I don't mean to leave you guys out here. So we'll jump into another poll question here in just a second.
I tried to get to that 70%. Okay, there we go.
Great. Thanks for being honest, because this is a really challenging piece to our industry, is setting those wellness energy goals on most of our projects. We're right there with you. That's something that we try to push for on projects, and sometimes it doesn't end up that we have a really well-defined goal. So what we've been challenging us, and what I would challenge you to do, is to push for setting those targets early on. And that's awesome. We've got a bunch of individuals or a bunch of people here who do set those long-term goals. That's awesome. That's great to see. Thanks, Danny. Okay, well, while we're on that poll thing, why don't we do one more? So within your firm, how would you say you are set up to be able to hit these energy and carbon mandates set forth by municipalities? Great. I think that is the sense that I feel in the industry as well, is that we're getting close, and we need to push harder to get to be able to hit these mandates set forth by our municipalities. Great, thanks so much for participating in that. We will keep moving here. So next section, how have we gotten to, on these special projects, what are some common themes? How have we gotten to that end goal of setting up a project that creates really good energy efficiency or really good occupant health? So here are a couple of themes that we've seen that we wanted to bring to you. So one is setting a path and mapping out that path to be able to get from where we are today to that end goal. So this is just a quick slide on getting to net zero that we talk about often, and sort of the process of getting from our baseline building all the way down to renewable energy. This is a project that we're working on with a confidential client where their goal was to have a really great indoor environmental quality for their workers, for this workplace client. And so we were able to use this tool, this calculator that we developed internally, to help define and understand productivity and putting numbers to how productive a worker was going to be with different environmental different pieces to the environment. So like daylighting was looked at, ventilation was looked at, air quality was looked at from a particulate standpoint, and there were a number of other factors in here, but this tool allowed us to quickly understand how each one of these was going to have an influence, and then it was able to guide our engineers and our architects to design the building in such a way that we were able to meet these goals. So this is a really neat tool that we've been able to use a little bit, and we'd love to use this more often. It's really, really effective for creating great indoor environmental quality, and has the data to back it up with. That same client was looking for really good daylighting in the space, so we took that first calculator, which said we need this sort of quality of daylighting, and we were able to analyze and tweak the architecture to make sure that what we were shooting for was actually being met from a analysis standpoint. And then at the end, which I'll talk about in a little bit, we were able to verify that what we had shot for, what we had designed for, was actually being met in the end. Another client that we were working with, similar case, they wanted really good indoor environmental quality for their students to learn. And so our group, and this is not really me at all that is doing this, we have some really, really smart people at Branch Pattern. So Marcel, our anthropologist on staff, he pulled together all of this information to help us understand what was the most effective ventilation rate, where we were not going to increase energy consumption within the building. So this client had a balance that they required, where we had low energy usage, but really good indoor environmental quality. So that meant that we needed to increase ventilation in the building, which also increased energy. So what we were trying to do with this study and with this data collection was to find that optimal point between the two. And what we found here was that what we should be shooting for is CO2, carbon dioxide, parts per million in the building to be somewhere between 1,000 and 700, and we were shooting for somewhere in the middle, which was about 800, 850. And I'll show you the results of that here in just a little bit. We also were able to show the simple payback within that increasing ventilation in the building, what that additional cost was going to be, and we're able to quantify the productivity from a cost standpoint to help figure out kind of, is this actually going to make sense? Will this pay back? The next thing is that everyone on the team must be able to iterate and iterate quickly. And a lot of times that's difficult for especially engineers who are linear thinkers compared to designers who are more iterative thinkers or revolving thinkers. So what we try to push, this is kind of our take on requiring or pushing our engineers and architects on staff to be iterative thinkers. So during the discovery phase, being able to think about a lot of different solutions, come up with a lot of different what if scenarios so that we can analyze and then be able to converge in on a solution. won't go into much more detail about our dive project framework is what we call this. But if anyone wants to know more, I'd love to talk more about this down the road. But the idea here is that we're iterating, and we're iterating quickly so that our analysis and our data is actually being used to inform the design. What oftentimes happens is the data is slow to get to the decision makers, and by the time it does get over, the design has already iterated 4 or 5 times and has kind of passed its past the opportunity to be effective. So here's one example of a project that we were working on where energy was the driving factor. The goal was to create the lowest energy consuming building that we could. And it had a kitchen in it, which if you're an energy follower, you know that kitchens use a ton of energy. So that was one of the places that we focused on first. But you can see here, there were a number of interim iterations between each one of these kind of bar charts. But you can see the impact of each iteration that created this low energy consuming building. Here's another quick example of iterating on geometric changes in architectural changes, really. So the goal here of this project, which is up in the mountains in Colorado here, just outside of Boulder, the idea or the hope here was that we were going to use no heating or cooling in the building. That's the best mechanical system, right? It's one that doesn't need heating or cooling. And so that was our goal here. So what we were looking at is how can we provide natural ventilation for cooling, and how can we super insulate the building so that the internal gains and the gains from the sun can heat up the space and allow us to float through the night. So we were looking at the minimum temperature in every room throughout the building, and through a number of iterations, we were able to get the internal spaces, the lowest temperature, to be 63 degrees in that climate zone. So this was a kind of a new way of coming up with data, but since we had that goal in mind at the beginning and we were able to iterate quickly with our design team, we were able to come up with a really good solution that made this project pretty special. And then finally, just a quick plug here in this little section is Cove Tool. If you have not heard of this tool, it is a really neat and robust tool that we've been using internally for really early conceptual design strategies and iterations. So it kind of helps at least limit the field or define the field a little bit better on different envelope types, mechanical systems, cost, EUI. So what you can do is plug in all of this information and then narrow down your field of what's most appropriate or reasonable to use within the building. So if you'd love to know more about that, that is a great tool. Check it out. It's cove.tool, and it's pretty user friendly. So this was kind of a catch-all, but something that I saw made project special, and I saw someone in the comments state this too, is having people on the team who think holistically about the building, not just within their silos. They can connect the dots for the team. Analysis groups are really good for that, or specialists on the team who can kind of jump between two different disciplines are just really valuable to have on teams, because they can see those connection points. So think holistically, thinking about people too, because our buildings are designed for people, and getting out of silos is really important. So I'm going to quickly go through just a case study of a project that we worked on, and this was something that I actually created for this presentation here. So it's a library project. It's 20,000 square feet. This is a theoretical project, and pulling all of this data together, this one iteration took 30 to 40 minutes to get this information together. So it's not a really big effort to try to pull together all of this information, but it is really valuable, I think, and that's what I hope you get out of this. So it's in rural Colorado, which is not a town; it's just outside of the cities, where the codes may not have caught up with today's current code. So you can see we're using ASHRAE 90.1 2007, and some of our insulation values or envelope values are located here. System, let's say we had that figured out as we were going into this analysis, and we're pulling costs from RS means. So walking through this scenario, this is something that on every special project, if you will, we've done this sort of analysis on. So the first thing is looking at climate and really looking at opportunities within the climate to be able to work with the environment or work with the climate rather than trying to fight against it. Now, there will be some of that, right, on every project, but as I said before, the best mechanical system is no mechanical system at all, or a very small mechanical system that doesn't have to run very often. So looking at the climate for opportunities is really, really valuable. Looking at wind within that climate, can we use the wind to our advantage? Do we need to block the wind for our advantage as well? So looking for some of those opportunities within the climate. And then looking at the building and how that building type is going to react to the climate and to the occupancy within the building. So really getting a good, firm understanding of what we're trying to target and where the problems may exist within the building. So here we can see boilers and chillers are going to be a pretty big target point or an opportunity for reduction here. And lights too. So taking the time to orient the building and create different massing schemes, which is something that I'm sure a lot of you architects, you 57% of the field out there are doing. You're looking at different options. A lot of times we get constrained, right, on sites that are within the city, but if we're out on a greenfield site, we're looking at different massing and orientations. So this is a really quick and easy way to understand how different orientations and massing are going to get different energy consumption values out. So we can see here, just by moving some of these different pieces around, you're able to get different energy consumption. So on this, by a show of hands, how many people tend to do energy analysis on their massing and orientation studies kind of right at the beginning of the project? Is that something that's designed into your workflow? Great. Seeing some hands there. That's great. Awesome. So being able to quickly do these studies early on can create, again, here, this is only 5% energy savings or something like that, which doesn't seem that significant. But down the line, when we get into mechanical system or active system design, saving 5% across the entire building just by changing a mechanical system is going to be really costly. Going from rooftop units to a heat pump system, that could save us 15-20%, but there's a really big cost delta between the two of those. So here if we're just moving pieces and parts around, the cost is not that significant. So this is a really good way to save energy free or at less cost than doing other active systems. Okay, so let's say that we pick this south-facing office model, which is that kind of light blue color, and diving into window-to-wall ratio studies. This is again a really good way to just get kind of some parameters around how the design can be optimized or function best. In this scenario, for this location, we have a point of inflection, if you will, here at 50% window-to-wall ratio. So you can see as you go up with the more, or I guess the more glazing you have on the building after 50% is going to have a significant impact on the energy consumption compared to less. So what we would recommend here is that going above that 50% point is probably kind of your stopping point, and it's going to be better if we can stay down towards that 30 to 50% zone. And then also looking at daylight. Now, these are not great graphics, so bear with me. We've got some other tools that create prettier graphics like the one I showed earlier, but just for a quick hit iteration, this is something that can provide us really good data to make decisions on. We can see here if we are going to do less than 50%, we're going to have some dark spots in here. And we all know daylighting creates better cognitive function. It creates happier occupants. So that's something that we need to take into account while we're designing the building too. So kind of holistically looking at this, I guess, is really important. Whereas if we go above 50%, we may have some glare issues within the building. So being able to take that data and be able to put that data to work, I think is really important. Insulation versus energy consumed. Again, we can see we have an inflection point here, which is actually about where our today's current codes are, just a little bit under today's current code, with exception to the wall. So increasing wall U value here in this scenario was going to be one of the best opportunities, and decreasing the glazing a little bit. So this is right here is where kind of the rubber meets the road, and where we can see the impact, where we should see the impact of this data analysis and this data collection. And that's through cost savings or cost sharing, really. So what we find whenever we select that insulation number 2 scenario here, we can see what the payback is with these different insulation rates here. Those two line up. But what we find is if we do go to the insulation 2 value, our energy cost savings is almost $15,000. But where it really helps us is in the plant cost savings. We can downsize our heating and our cooling plant. We can downsize our air handling unit. And those are costs that really should be factored in to all of this data gathering. So whereas simple costs by just accounting for energy savings, maybe 10, 12 years, factoring in that plant cost savings gets to 1 or 2 year payback. So again, what we're doing is cost sharing. We still have the same budget, total budget, but the amount of budget that's going towards the mechanical system is less, and we're able to put that money into the envelope system, which is going to last a lot longer. We've seen studies here recently that show in a lot of rural areas that really super insulating the envelope and creating really simple mechanical systems actually has a cost neutral end result, but energy efficiency goes way up, so we're way more efficient, and maintenance costs goes way down. So if you'd like to talk more about that, or if you have experienced that or seen that, throw a comment in the comment section there. I'd love to hear from you on that. And then this is the last thing that that we came up with here is to verify that our goals that we were shooting for were achieved. So we talked about that a little bit earlier on in the presentation, but this is a really key component to understanding if the analysis that we're doing is correct, if the goals that we're setting are reasonable, to be able to go back and check and verify. So our commissioning group and our internal engineering and analysis teams have an initiative that we've started that requires that A, we set a goal, and then B, we follow up with that goal and capture that data so that we can make even better design decisions on the next design that we're doing or the next commissioning project that we're doing. So here's a project that was brought up previously where the owner wanted really good indoor environmental quality, but they also had really aggressive energy goals. And this project, we went back in and analyzed how their CO2 parts per million were lining up with that. I think we were shooting for somewhere between 700 and 900 parts per million. So 800 is kind of that middle zone. So this graph is a little bit hard to understand for me anyway, so I'll kind of explain a little bit. So this is the percentage of time throughout the year that we are less than 600 parts per million for this black line. So here in March, we're 50% less than 600 parts per million. Less CO2 in the space, or conversely, more fresh air in the space creates better learning environments. There's a lot of data around that, a lot of research around those claims. So reading this graph, you can see that we were close. We didn't hit our goal here, so I'm letting you in on a lesson learned for branch pattern that we're going to apply to the next project here. So, but you can see that we, for a lot of the school year, we've created an environment that is potentially more exceptional than what we would get from just a code building. So in our code buildings, just for a frame of reference, we're seeing anywhere between 1,000, 1,400 parts per million is a kind of new, a newly designed building. Existing buildings, we can see levels up to 2,000, 2,500, which it creates sleeping environments, I guess, really, really tired kids and occupants. And the other piece of this was really good energy consumption. So we had a goal of 25 EUI, which is measured in kilo-BTUs, which is an energy consumption per square foot per year. And so an average building would be about 79. And this project that we worked on, the goal was 25. The analyzed data was 27. So we, through the modeling process with one of our partners, we found that 27 was kind of what we thought we were going to be able to achieve, and the building is actually performing at 30. Now, I think that 30 number, I really think that some of that is based on the operations of the building and things kind of getting up to a consistent state. So I'm hopeful, and check back with me in a year or so, and hopefully that number goes down to that 27. But what we were able to do here is move the goal, because we had this really aggressive indoor environmental quality requirement, and we had this really aggressive energy target. So we were able to find that optimal point. We were able to state the goal, or restate the goal rather, and say, okay, instead of 25, let's shoot for 27 so that we can increase ventilation air and try to hit both of these targets. So that made that project really special. Okay, putting it into practice. Let's get this wrapped up here. I think we just have a couple of minutes left before, and I want to leave a little bit of time for questions here. So these are some takeaways of actually putting this into practice within your firm. And I would love for you, if you can, add some comments to the comment section. Let me know how you've actually integrated this modeling or this data collection and data-driven decisions into how you're designing, or how you as an owner are requiring these buildings to be designed. So here's a couple of things that I found. It starts with the leaders to push this along or require this from the design team. And then it takes trusting the results, and it takes trusting the experts who are coming up with those results. And it really takes an investment within the entire team to be thinking about how their piece of the puzzle is going to impact the whole design. So you may be thinking, hey, Mons, this all sounds great. This sounds like a really good pitch for Branch Pattern to do data analysis on every project. And that's exactly right. No, I'm just, I hope you're smiling out there. So yes, we love doing data analysis on projects. That's very true. But what I'm advocating for here is not that Branch Pattern do it on every project. What I'm advocating for is that every project have analysis done on the project, because this data is so easily accessible, and it's really effective. It really affects how we do design. So we've seen and experienced really successful projects where the analysis is done by Branch Pattern, or in the architecture design team. We have a client who does their own analysis and helps that data drive our design team. So if nothing else, having someone on the team be dedicated to analyzing and figuring out these what if scenarios. I keep saying what if scenarios, and those are just, when you're in a design meeting saying, hey, what if we do this? What if we do that? And being able to have data quickly to help make those decisions is really, really impactful. So a way to do that is bringing your modeler, who is right now possibly outside of those design team meetings. This is a good self-portrait here of me doing my modeling on my laptop there. So this happens a lot. You'll have the design team creating and making decisions, putting it over to the modeler to verify if those decisions are correct or thoughtful, and then bringing that information back maybe a couple of weeks later. And what I'm pushing for in our design charrettes, and what I would challenge all of us on, is to bring that person into those charrettes. We've done internally at Branch Pattern with some of our design projects, we've done analysis in design charrettes. And it creates really good results, because we can say, what if we do this? The analysis person says, okay, here, let me run that real quick, gets that information out quickly, and we can continue on with our design decisions. So your modelers can do that, and I would ask that you bring those analysis folks into those discussions to help inform some of these decisions. Okay, finally, last slide here, and this is one that we internally have been talking about a lot, and I've talked with a number of you on the call here about, is how can we continue to front load our design schedules so that we can have a little bit more time in pre-design, schematic design to help us analyze the design solutions that we're coming up with, analyze these what if scenarios, and create better decisions and more special buildings. I think it is going to take us allowing for more time within those periods, pre-design and schematic design, but it's going to require us to build that into our schedules, which is really difficult to do because most owners, builders, even architects, and leaders expect the pre-design schematic design to be pretty quick. So I would love to hear from you how you've been able to incorporate this in on your projects. But I have seen that when there is a little bit more time in pre-design and schematic design to dedicate and fee, I guess, during those times to dedicate resources to analyzing this data, it's really, really effective in creating really special buildings that can go from average to good and from good to great. So let me know what you think about that. So with that, I think we've got, yeah, great. We've got a couple of minutes here left to answer any questions that you have. Or if I know we've got a lot of experts, like I said, if you have comments on here of something that you'd like to throw in, this I think is an open forum, and I'd love to hear from you, or we'd love to hear from you. So please go to the question and answer now, and we can jump in.
Before we get into the Q&A, it looks like we do have one more poll about how many projects you have verified that your goals were achieved. If you want me to launch that, Miles.
Oh yeah, please do, Danny. Thank you.
Mm-hmm.
So the question is, how many projects have you verified your goals were achieved on energy consumption or occupant comfort?
It looks like just over half of our attendees have responded, so I'll give it a couple more seconds.
Great. That's awesome. You guys are so engaged. This is fantastic.
Okay.
Great. Again, thanks for your honesty on this. Yeah, I think this is a really good way to understand how our buildings are doing. And it does take a little extra effort, but the results and the lessons learned that we gained during that kind of post-occupancy evaluation period creates and sets us up for the next project that we're doing. So for those of you that are owners or designers, it's a really good feedback loop to learn from projects. So thanks for taking that. That's great.
It looks like we do have one question in our Q&A box here. So I'd encourage people to get your questions in. Again, you can ask them anonymously if you don't want your name to be associated with the question. But here, Bruce asks, how quickly can you turn your modeling analysis around in real-time charrette? What do you mean by quick results? Several minutes, 30 minutes, immediately? How far away are we from real-time dynamic modeling where a what-if question is answered right away?
Yeah, that's a really, really good question, Bruce. And it depends. So two years ago or 5 years ago, I would not even be comfortable saying we can do a real-time charrette. 2 years ago, a lot of modeling tools have come out with ways to create these kind of real-time dynamic modeling functionalities within the tools. So what it does take is, and then now, I guess I should say, now, I think a lot of analysis groups have caught up with some of those tools and are able to use those effectively in meetings. Not every analysis group, but I would say there are some that can do it and do it effectively. What it does take is some pre-planning for a meeting to know where our trouble spots are and where we're going to focus our attention today within this charrette. So it does take some intentionality on the design team and the ownership team to understand how this functionality is going to be used in the meeting today. But we've done, and it takes, 10 minutes to set up and 10 minutes to run the model. So 20 minutes maybe for an iteration within a model within a real-time setting. So for example, we did a project here recently. It was a bank project. There was a lot of glazing on the building, and our units, our mechanical units, were really blowing up in size. And so what we were doing was looking at the mechanical units and looking at the glazing amount on the building. And so within that framework, or within that charrette, we were able to focus in really tightly on specific things that we wanted to analyze, but we needed multiple people in the room, multiple decision makers to be in the room. So yeah, that's how we've done those real-time charrettes. Another thing, if you look back at that Cove tool model, that's a really good way as well to do real-time charrettes on a lot broader scale. So you can look at windows, insulation values or envelope values, costs, mechanical systems, all sorts of things like that. So it creates a way to have discussions around all of those different pieces. So I hope that answered your question.
Thanks, Miles. And the next question we've heard a lot. How do you overcome the objective that net zero design is cost prohibitive to the client?
Yes, that is a really good question. And oftentimes there are certain pieces to getting to net zero that are cost prohibitive, as you're talking about. So what we've found to overcome this challenge is to try to set those goals up front and set those expectations up front. What are the budget constraints that we have? And if our goal is to hit net zero, what's the budget gap that we need to hit to achieve net zero? However, what I've found is that a lot of times, if our goal is stated early on in the project, for instance, to be net zero, and there's enough time within the design team's schedule to come up with a solution, that we can get very close to net zero or net zero already. For instance, we worked on a school here recently where the client had aspirations of being net zero, and our team came up with a solution really early on that ended up resulting in a super insulated envelope, a really, really simple mechanical system that was small, and the cost of the whole thing together was very similar to a kind of traditional high performance building, where you have a pretty good envelope but a really complicated and low energy consuming mechanical system. So what we did find in that situation, though, was that they were not today able to purchase photovoltaics to overcome and hit that net zero target. We did set them up for future expansion of that, and we gave them the cost. We worked with them to figure out how they could pay for it now through PPEs and things like that. So yes, you're correct. There are a lot of challenges and barriers to overcome, and budget is a really big piece of that. But I would say that there are things that the design team can do to try to get as close to that objective as possible.
To add to that too, I think we see that buildings that use less energy or are more efficient tend to also be healthier. And that happy tool you mentioned very early on in the presentation is a good example of how we can create payback periods that utilize health metrics to show the owner that there's a quicker payback than they may have realized.
That's a great point. Really good point.
Okay, I had another one here, and I'd encourage you to please ask your questions. How often does the modeling analysis vary from the post-occupancy data? Have you ever been led astray by the analysis?
Yes, yes, we have. that that does happen, and it takes a design team and it takes an analysis team to identify if the analysis is or the data is leading us in a direction that is not real or not consistent. Because a lot of times, I'm sure you've experienced this too, or it sounds like you've experienced this. A lot of times we can make the energy model say what we want it to say, which is not good data gathering. So it takes a disciplined analysis team to input the information that is consistent and correct, and it takes the design team to be able to feed that information so that it is correct, so that we can use the tools that we have to make really good design decisions. So a lot of times the models that we put together are checked by a number of different people, and some people do kind of a gut check, like what's been your experience on past projects that have been built that we have the data to compare against. So that's a really, really good way to verify if we're close. But then also we do more detailed checks to make sure that the information we're inputting is consistent, is reasonable, and if we're making assumptions, that we're stating those assumptions and we're trying to get clarity on those assumptions as much as we can, because that's where we get led astray the most, is when our teams are making assumptions that are not correct.
There has been a couple projects too I've overheard about where we are not the team doing the analysis, but we are doing the MEP design, where we may not agree with the analysis that the other firm is coming up with. I don't know if you want to talk about bridging that gap or how to navigate that conversation.
Yeah, that does happen external to us. It happens internal to us too. I think when everyone's invested on the team to come up with the best solution and make sure that we're coming up with the best data, that the numbers should be scrutinized a lot. So yeah, we've had that experience where there's a third party or an outside consultant doing the analysis, where we'll check it over. That's just, I feel like, part of our job as an engineer, when we are the engineer, is to understand what's going in to the model and make sure that that information is correct and consistent. And when the results are not consistent or correct, that we dig in and find where those inconsistencies are. So that's something that I would challenge our team to do, and I would challenge our industry to do, is to work with our analysis team to make sure that they're providing us really good real-time data results.
Thanks, Miles. Here's kind of a unique question here. After running models for different buildings in the same area, like in Colorado, do you see rule of thumbs appearing for each category, like window to wall ratio, or are there wide differences based on building type or other factors?
Yeah, that's a really good question, because you would think that with a certain building type, and certain occupancy in a certain climate, that there would be some consistencies, and there are. So there's some high performance design guidelines that ASHRAE puts out, that what was Pete Jefferson, if you know him in our office, he's worked on those for a number of different building types, but there are, because a lot of the information is the same within buildings, within climate types. So what I would say to that, though, is that's a really good starting point for starting a design, a conceptual design. What I would recommend, though, and what we try to do, is we start with those assumptions in mind so that we can start to kind of diverge, so we're not, analyzing the field. We're analyzing these things that are recommendations. But there are inconsistencies and uniqueness to every project that are going to create differences within the results that we're not accounted for in these high performance design guides. So yes, rules of thumb are a really good starting point, but oftentimes there's enough inconsistencies within the building to require or suggest that doing analysis to help create divergence, convergence on a solution is that's what I would recommend.
Okay, we have 3 more, and if we don't get through all of these, we will be doing a follow-up discussion I'll talk about in a little bit. So follow-up to the net zero cost question. Several of our clients are developers who intend to sell the buildings shortly after they have been completed. How do you approach net zero design in a situation like this, where the developer is not necessarily concerned about return on investment and energy costs?
Yeah, that's a really good point, and we've experienced that as well. I think it does require that we, well, first of all, I think a successful building does not necessarily have to be net zero or super high performing. Although
Yes.
that would be great if we can do that. Well, we do a lot with developers who have that frame of mind, because that is part of our society and our how the economy works, and it really does add a lot. We still can use data to help those developers who are thinking first cost only. And so going back to that analysis that I showed with the library, where we're looking for trade-offs so that the first cost budget doesn't go up, but we're able to take money out of certain parts of the building and move them over to other parts of the building, so that it does result in a more efficient building, or a better environment for occupants. Going back to Danny's point, the other thing that we find too is that understanding what's going to be most important to a client helps us drive the data that we're presenting to the design team. So if a first cost minded developer, if we start talking about net zero or lifecycle cost or carbon footprint, oftentimes that doesn't really resonate with that developer, that owner. But what does is first cost, higher rent per square foot, better return on investment. So coming up with metrics that we use to analyze our building design that result in those sorts of talking points have been really effective in creating better spaces, better energy efficient spaces that are not more first cost. But as you brought up, and I want to affirm that, it is a really big challenge within our industry, especially as codes continue to change, to have cost-effective first cost effective design solutions that are going to meet code and not increase first costs for our clients. That data and doing the analysis is really the only way that I've found to be able to make those really good decisions.
Great. We may be able to combine these next two into one question here, and then we'll wrap up. So what are some examples of how analysis can be used in renovation projects? And then on average, how often do you see clients and owners interested in modeling analysis?
Yeah, so oftentimes clients and owners are interested in the analysis or the data behind the analysis, because I think everyone wants to make decisions based on numbers or something quantifiable. So in my experience, being able to say, oh, we can do that analysis. The other day we were working on a police station project, and traditionally they have used a makeup air unit. We suggested using an energy recovery device in the building, and the only way we were going to be able to say, hey, this is the better solution, is if we said, you're going to hold the building for 30 years or 50 years or whatever, and this is going to be your payback number, the payback amount, and the maintenance cost across the building, or across the lifetime of the building. So most people want that information. Now, oftentimes it's difficult once we're in the project to try to add a service to get that information out. But I think it really requires the leaders on the team to be able to say, this is a really good investment in understanding how this data should be making an impact on us. And a lot of times we, like for that one, it was in the best interest of the owner to have this information, and so we just did it because it was the right thing to do at that time. And it didn't take that much time to be able to get that information to the owners. So sometimes for little things, little data to provide to owners, we just do that quickly. Other times, if it's kind of a big, like starting in conceptual design, where data really should be started, that can take really good understanding on the owner's part, really good understanding on the design team's part to say, this is going to pay for itself, this service is going to pay for itself, and the results are going to be useful decision-making tools for us throughout the design process. So that was that question. In renovation projects, we see this happen all the time, because renovation is really where our energy consuming and poor indoor environmental quality is currently, and we have an opportunity to change things within that renovated space, but we can't change everything. And so being able to use data to help us identify the biggest impacts that we can make with changes to the existing building really go a long way. So I would almost argue that data analysis on existing buildings is more important almost than on new buildings, because we have the new building codes with new buildings, and those get us really far. I don't think they take us all the way there, but on renovations, we can decide to improve windows rather than replace the mechanical system. Is that going to be the best use of our money? The only way to really figure out that specific scenario is through analysis. So being able to analyze the different components of the building, see how they integrate together, is a really, really big component of existing buildings, and why I would advocate that analysis is key to having a special project on renovations.
Thanks, Miles. If you could flip to the next slide. And I'm going to launch this last poll here. So we would like to do a dialogue of this topic. So if you are interested in participating in a follow-up discussion, where we can see your video and hear from you. We'd love to get that scheduled in the next few weeks. And then I would like to call attention to our upcoming webinars. Next, we have them on the 3 following Wednesdays. So this coming Wednesday, we have Net Zero Hospitals, Past, Present, and Future by Rick Maniktala. The following Wednesday on the 15th, we have The Human Side of Successful Daylighting and Lighting Design by Marcel. And then our webinar on Earth Day by Pete Jefferson, The Energy Health Nexus, Achieving Energy Efficiency and Indoor Environmental Quality Together. Again, we'll send out a survey. That's how we'll collect your information for AIA and a certificate of completion and send you the slides. So please take that survey. All right. Thank you, everyone. Thanks, Miles.
Thank you. Yeah, thanks so much for your time today, and thanks for your participation. That made this a lot more interactive, and I really appreciate your attention. If you do want to follow up, be sure to join in on that follow-up discussion. I would love to hear from you and learn from you and what you've done. The best way to continue to push each other is to have those forums, I think, to find opportunities to challenge and grow each other. So if you want to do it in that way, or if you want to shoot me an email, I would love to talk to you. So thanks so much for your time here today. This has been really fun.